Now I want to explain this article, supervised hierarchical clustering with exponential linkage. This important article about hierarchical clustering. But we use the supervised paradigm and we use exponential linkage. So it's not just single linkage. It's a weighted combination, and you will see. So the motivation is that in supervised clustering, standard techniques for learning a pairwise dissimilarity function often suffer from a discrepancy between training and clustering objectives, leading to poor cluster quality. Rectifying this discrepancy necessitates matching the procedure for training the dissimilarity function to a clustering problem. Naively training the dissimilarity function, those phi and psi that you will see in the future lectures, to predict whether the data points belong to the same cluster does not lead to robust generalization on unseen data. For example, in the context of zero-shot learning, unseen data, you're working, for example, with unseen data that you only have a brief description of that, not fully labeled things. The idea of this paper is that they introduced a method for training the dissimilarity function in a way that is tightly coupled with hierarchical clustering, in particular single linkage. However, the appropriate clustering algorithm for a given dataset is often unknown. Thus, we introduce an approach to supervised hierarchical clustering that smoothly interpolates between single, average, and complete linkage, and we give a training procedure that simultaneously learns a linkage function and a dissimilarity function. So it's a joint learning. I mean, traditionally they use it separately, but now we use it jointly. So what is hierarchical clustering? A brief introduction is a method of clustering that builds a hierarchy of clusters. So it's either top-down, you go bottom-up, because it's called agglomerative, or divisive, which is top-down. And so we care about in this paper on the agglomerative, so we go from bottom-up, from these leaves to making it bigger and bigger and reducing the number of clusters. So what is supervised hierarchical clustering? Clustering algorithms are pervasive in data analysis, pre-processing, modeling, and visualization. While often an unsupervised problem, in many cases there exists a small collection of data points that are labeled with their ground truth cluster assignments. But what is single linkage clustering? Single linkage clustering is one of several methods of hierarchical clustering. It is based on grouping clusters in bottom-up fashion, as I said, agglomerative clustering, at each step combining two clusters that contain closest pair of elements not belonging to the same cluster. For example, there are some mentions here, some mentions here. This mention and this mention have highest similarity. So they combine, and we find that so at each step we combine the two clusters that contain the closest pair of elements. So for example, this is single linkage case, that from one of this from this, and then you just the minimum. So it's the simplest one. You just take the minimum, but the complete linkage takes the maximum of the distance between two clusters. And but the average link, do it for all pairs, for all of them, not just the best one. And for centroid, you get the centroid. So it's like the distance between this mean and this mean. And what is single clustering? As I said, it's just the minimum of the distance between the two. For example, in this paper, we're talking about mentions. Each mention links to one entity. So for example, if this is the entity, and these mentions are linked to each other, and we have another cluster that has lots of mentions and represented by one entity. So each cluster has just one entity, but several mentions in this paper, which is about natural language processing. Of course, this paper is not about NLP, but the authors have written another article, which I will explain in my playlist for entity linking, that use this paper. So it's a very important article. So what is exponential linkage family? We establish such a family by expressing each of these three linkages as weighted sum of across cluster dissimilarities. The weight of an across cluster dissimilarity is formed by scaling that dissimilarity by a real valued hyperparameter, exponentiating the result and normalizing, computing a softmax with respect to all other pairwise dissimilarities involved in the merge. We call this family of HAC linkages the exponential linkage family. So the supervised clustering, we are provided by X and Y here, be a training set where each X is a collection of MI points and YI encodes the ground truth partition of XI. The goal is to learn an algorithm that accurately cluster a new data set. This X is new. I mean, we haven't seen such data. That's why the intersection of all of these training and the things that we haven't seen is empty, because we haven't seen that. So it's an agglomerative. We're going from bottom up, bottom to top. And for single linkage, as I said, we use the minimum distance. But here the distance is the similarity. So, for example, in article for entity linking, we have phi and psi. For example, phi distance between two mentions, mi and j, and psi, for example, distance between mention and, for example, entity. And of course, the link between minimum spanning trees and single linkage clustering, it has been investigated, but it started in 1969, so we knew it from several years ago. And in all pairs training, we do it this way, but this is prone to many problems. That's why this is important marks for me. It means that this objective has a mismatch. Under this training objective, misclassifying within and across cluster are equally penalized. For example, there are lots of mentions here. You don't care that this one or this one, you don't care if the distance is big or even the distance between these. So you don't distinguish in between cluster or across cluster. And that's why we have some problems here, but we will remove this problem by this minimum spanning tree based training. So the idea is that you have a training data, but you can easily create your minimum spanning tree of a cluster. And so we want to increase this, reduce this and increase this one. We want to increase the similarity within and dissimilarity across. And so this is the algorithm that you're using. So first we use minimum spanning tree on the training data, because we have a training data, so you can easily create the minimum spanning tree by just removing the unnecessary links that creates something that is non-tree. And so a minimum spanning tree removes our problems. I mean, resolves our problems. But we introduce another measure. This measure is important because when alpha goes to minus infinity, it approaches that pairwise dissimilarity. And when alpha goes to infinity, it is just complete linkage. If you remember, complete linkage is the maximum between them. So it's a bit of a both world and many other worlds when we vary this parameter. That's why it's like a generalization, because it captures all different scenarios, different approaches. And we can look at it as a hyperparameter. I mean, I always look at this alpha parameter as a hyperparameter. And this is the training exponential linkage problem, that now we have this measure psi, and we use this loss function. And now you see that in exponential we have a better clustering in comparison to this single linkage that everything is not fair. And we use 4 data sets for this supervised hierarchical clustering. The thing that I care is this NP coreference and Rexa. And Aminor has this publication records of authors. We have 100 blocks. Each pair of publication is represented by 8-dimensional vector. And that's it.